All right, our next presenter is Xing Fang, PhD. Dr. Fang is the co-PI for the NCHRP Synthesis Project 5311, Resilient Design with Distributed Rainfall Runoff Modeling. He is the Arthur H. Fegan Chair Professor in Civil Engineering at Auburn University since 2014 and worked at Auburn since 2007. He was a faculty member in the Department of Civil and Environmental Engineering at Lamar University, Texas for 12 years. He is an accomplished researcher in areas of surface hydrology, hydraulic analysis, and modeling. Dr. Fang has worked on 22 funded projects related to hydrology and hydraulics as the leading PI or co-PI for 3 DOTs, Texas, Alabama, and Iowa. He has also worked on 32 funded projects from various funding agencies. He has published 126 journal papers and authored 62 project reports for funding agencies. He also served as the associate editor in surface hydrology for the Journal of the American Resources Association Hydrological Science Journal. Welcome, Dr. Fang. I don't know where you're at here. This one. Perfect. You got it from there? There you go. Yep.
Okay, good afternoon, everyone. Thanks for the introduction. So basically, you had a presentation from Dr. Lai talk about the very advanced hydrologic model. So now I'm pulling back to the reality. So this is NCHRP synthesis study assessing the state of practice of hydrologic modeling for the state DOT. And Dr. Vasconcelos is the PI for the project, and he was planned to be here, but due to the family medical urgency, so I, as a co-PI, came here to make the presentation. So we have 3 graduate students work on the project. So I'll give you some context of this synthesis work. And as the synthesis, we have done the literature review. We'll give you some results about that. So we conduct a survey, show you the response from these DOTs. And then we have to do the interview for some DOTs. And for some case study, we'll give you some information. And then we'll summarize the work and some suggested future research for that. So give you a quick background. And this study is related to resilience design with distributed rainfall runoff model we call the DRRM. And as Dr. Lai mentioned, we'll mention that. So what is the DRRM? So basically, increase the frequency of adverse conditions such as extreme rainfall events, as mentioned in some of the presentation today related to climate change, and also happening in some states. Inland coastal flooding pose a challenge for the roadway infrastructure for DOT, so they need to do some hydrologic study. So we have 2 types of models, which we'll discuss next. So one type of model we call the lumped hydrologic modeling. So basically, it is a rapid, convenient estimate of peak flows, sometimes give you the simplified hydrographs, and typically associated with some hypothetic or synthetic design stone, because that's for most DOT for the design, okay? So basically, these approaches try to group or lump some dissimilar watershed area and together as one watershed. So for distributed rainfall runoff models, DRM, and is talk about the spatial distribution, divide the watershed undergoing study into small spatial element. Because of that, as I just mentioned, different hydrologic process are present in each spatial element. So more detailed or accurate representation of runoff formation, either from overland flow and transport if you're dealing with the water quality, and accumulation through the routing and go to downstream. So basically, DRMs enable more representative hydrologic description of the watershed, support effective decision-making regarding hydrological risk and resilience design. And that's what we need for the future. So we're following this diagram from one of the EPA report by Citizen. And A is a lumped model, and B is a semi-distributed model, divide watershed into sub-catchment or sub-basin. And C is a distributed model by grid cell. Sometimes they call the fully distributed model. So for this synthesis study, so based on our discussion with the panel member, so eventually the distributed rainfall runoff model include the case B and C. So both a semi-distributed or fully distributed model. And so basically, you say, we only use maybe lumped model for small watershed, 1 acre or few acre. But in the reality, for the highway design, they could use into very large watershed. So you know, like the USGS stream stat has been implemented almost all 50 states, maybe only 1 or 2 left. So if you use a stream stat, you zoom into your road system, you want to put a bridge or road crossing, so you select that point as outlet. Then they do the watershed delineation. Then they determine like the area, maybe slope, or maybe stream length. And then they pop up lots of the results, the peak discharge for return period, 2 year, 10 year, 50 year, and 100 year. Behind that, they essentially apply a regression model, which developed, we don't know how many years ago. Okay, so basically, if you make some changes in that watershed, no matter what you make, but if you use a stream stat, they just apply that regression equation, and no matter how many times you go there to try, you get the same result. Okay, so they cannot reflect any changes, so they cannot link to the resilience design until you hire the USGS or other research redo the study to develop another set of regression equation. Then they may have some changes. And also, if you look at the regression equation, they produce these values, but you also need to look back. They give you like a standard error, and sometimes that percentage is huge. Okay, so for the design, you may just pick up that value, but you need to associate the risk for that. But anyway, so that is kind of lumped model. In the reality, it could use into a very large watershed, but it's supposed not doing that. Okay, so these are the synthesis objectives and main tasks, and for the 20-05 and topic 53.1. So the goal is to document the state DOT use the DRM in hydrologic analysis in the context of bridges and the roadway projects. So it may not so linked to some urban stormwater management, because more linked to the DOT projects. Okay, so to achieve these objectives, and we performed literature review on each state DOT hydrologic design practice. So we find out each their practice menu and look into their hydrological model description and what are their typical applications. So we also evaluate the published studies applying the DRM in transportation in the past 20 years. And we developed a questionnaire sent to all the state DOTs, and we got a pretty high response rate. And then we interviewed some state DOT personnel. And so synthesis report is in draft first version. We got some comments from the panel. So we revised. I think we are sending the second version just in the next 1 or 2 days. And so the final report should be available at the end of the year. So the first part is literature review. So we provide some background information about the DRN, the types of the model, and the characteristics of these models in the literature review. And specifically, we surveyed some public available DRM tools, such as U.S. Army Corps Engineering. You're familiar with HEC HMS and HEC RAS 2D, because we are talking about watershed modeling, okay? And the GISHA, the EPA model SWIM 5, and the US SHR 2D, as Dr. Lai just mentioned. And we summarize the capability of each model in a table format. And so based on the survey on the state DOT's hydrologic design manual, and hydrologic design guideline was recently updated after 2015. And so we look at those manuals. So most DOT, about 98%, are referenced the lumped approaches in the design guidance, okay? And that's what I say, the status or maybe the current reality. A small majority of the DOT, 54%, reference using the distributed rainfall runoff model. And the most referenced DRN is HEC HMS, maybe the WMS-based model connect to that. And they sometimes use the HEC 1, the DOS version, or SWIM model. So for the literature review, and we surveyed the National Transportation Library, and on the application of DRM for found 30 studies, and out of 30 studies, 47% this study was preferred in the past 5 years. Okay, the focus of this study was to evaluate transportation resilience to flooding, or evaluate bridge scour or stream bed mobility, sediment mobilization, and aggregation. Some is stormwater management in terms like peak flow and water quality. The DRM most frequently used in these recent studies are still HEC HMS and SWIM 5. So then we developed a survey questionnaire and sent it to the DOT in late January. We got response from 47 state DOT, plus Puerto Rico Department of Transportation Authority, and also the DC DOT. So we got a 91% response rate for that. So the survey structure was simple. So 2 initial questions was common to the DOT, that you are using DRIM or not, okay? So if a DOT response indicated DRM was not used, then the next 2 questions focus on the key factor using the lumped hydrologic technique. Otherwise, the response from DOT will go through other 18 questions, give you some response, more information about DRM. So basically, we have these states response to survey, and those did not, okay? And so we have about 16 states response that they are using the DRM. So the white one, they say, is not using, and then those states with the dot, we have done the interview. So just give you a quick picture. So such as the question 2 for our survey. So what type of hydrologic modeling techniques does your agency use for the roadway project? So we have 16 states, or 33%, they say they are using the DRM. And then about 43 states, they are using gauge data analysis to determine the peak discharge or regression equation, such as a stream stat, okay? And those are 90% of the DOT. Or they use a rational method for peak discharge determination, about 85%. And there's 16, they also use other hydrologic methods. So for those mentioned that they don't use like the DRM, the next question is what are the factors and advantages that determine the use regression equation and all rational method? So you can see 81% they say is easy of use, okay? Especially for your design, I mentioned the string stat. You can just go online and then type an address, they'll zoom in, and then you click on a point. Soon that is the outlet of your watershed, or maybe that is your stream crossing for your roadway design project. They'll start to delineate the watershed and then get some watershed parameter, they'll pop up the estimates. So yes, it's really easy to use. Organization familiarity, so because maybe they have been used for a long time, so that's also 81%. There's few, maybe say that's required by regulation or maybe economic feasibility, okay? So for the DOTs, they do use like a distributed rainfall runoff model, and then we check, so which distributed rainfall runoff model or model components has your agency used? And there's only 3. They say there's some agency developed, adapted maybe spreadsheet runoff model, but you can see 75% they use HMS and 44% use like SWIN or XP SWIN. There's a few states use SHRD 2D, rain on the grid. I know they use HECRAS maybe for flood modeling a lot, but the link to the watershed 2D, so that's still a small percentage. And the GISHA actually is really grid-based, and they say 0%. But I think maybe in the interview, we know there's one state actually use GISHA, so they may not be represented. There's 2 states use a to-the-flow, and then one state use the microsheet, the DHI model. So that's just give you some idea the popular hydrologic models current DOTs are using, okay? So the question 6, what are the factors, advantages that determine the use of distributed runoff run model by your agency? And about like 11 states or close to 70% is talking about the watershed characteristic, okay? Based on the soil, you can use the information from soil types and the land use and slope, and to be more accurate do the hydrologic modeling, okay? And also there's 9 states, about 56% in 2 areas, is a better spatial representation using the grid or maybe sub-catchment or sub-basin. And using the DRM, you can do better modeling for runoff transformation to do the like river routing or reservoir routing, and all better representation estimation of rainfall loss, okay? Because in the lumped model, it's just a black box, okay? And whether you use a grid or use a sub-basin, and you can specify different loss method, you can do some calibration if you have data, okay? So the question 13, I mean, I do not intend to show all the questions, just some of the interesting questions. So what are the rainfall data typically used in distributed rainfall runoff model by your agency? Okay, and I think majority, most of them, 88%, is design rainfall depths for different return period, because that is particularly true for like the DOT for their design tasks, okay? And so there's about 8, and design storm rainfall distribution over the time, and so 6 historical rainfall time series for rainfall event. Maybe they use that for the model calibration. And when we talk about the resilience, we also want to get an idea so about the future, the rainfall prediction. So using future graded rainfall, like from GCM, either downscaled, there's only shows 1 response over there. So what components or metrics does your agency include assessing the cost and the benefit regarding use distributed rainfall runoff modeling technique? Okay, whether that is a fact to select the lumped model or DRRM. Okay, so we have 9 DOTs out of 16. They talk about the accurate design to size drainage structure to reduce the project cost, or because that project is important and critical for roadway project. So instead use a lumped model, they use the DRRM. Okay, so these are some results for specific questions and additional insight through the survey. Most DOT, about 63%, have been using DRM for more than 15 years. For those days, use the DRM. So from that point, there's a long history used DRMs. 88% use private consultant and into the DRM study, but also 81% say use the in-house engineer. So there's some overlap over there. 2 most commonly guidance used by the DOT for DRIMs are maybe federal guidance document and published by the FHWA or US Army Corps Engineer, or maybe soft user manual. 3 main factors report are the barriers for the implementing DRM. One is insufficient in-house expertise or lack of training opportunity or workforce turn around, and so they're not able to do the DRM. Okay, so after survey, and we also contact a number of DOT and conduct interview. And so such as NCDOT evaluate the resiliency for I-95. I think one presentation mentioned that corridor against extremely flooding condition. And so they use the HMS on the up part of the watershed. Then they use the rain on the grid modeling with the HECRAS 2D. Okay, and in here is a very brief description in the report. There's a little bit more detail, also reference to their other literature. Kentucky evaluated overtopping of the KY 1115 created by the intensive rainfall in the Stanton, Kentucky. So they proposed like a conveyance improvement. So they basically use the swim file for different scenario and for different type of rainfall. Caltrain, they compute like a 100-year return period discharge in supporting the scour evaluation. So the scour, you need the flow as input and for structural crossing. And so they use a graded modeling model, which is GISHA, to verify some of the results. And TechStar studied the flooding on the Highway I-10 for a long stretch, because for first street study, they're dealing with a small watershed or maybe large watershed, but I-10 is over 90 a mile or more, something like that, long stretch of the highway. As a result of intense rainfall, like in Sabine-Neches, Trinity River watershed, and also that part of the highway is linked to the Gulf of Mexico, so there's a storm surge. The study is still going on, but basically, this is a study that use distributed rainfall and connect to the HMS, generate some discharge as the boundary condition. Then they use the 2D tilt flow and to model like the runoff part. So for the watershed, the grid could be caused, but when they go to the highway, even the median of the highway, they made the grid cells to be pretty small. They can resolve the special characteristic in that level. They use the tilt flow. So this is kind of like the summary and of the state practice of hydrologic modeling and for the state DOT. So again, the lumped hydrological techniques like the regression equation, sometimes maybe the rational method, or maybe modified Russian method are still widely applied in the state DOT. So that's the current state. So the distributed rainfall runoff models are competitively less used. It's only 33% of the survey respondents or DOTs mentioned that. Okay. So even we find some discrepancy. So when we look at their state menu, they mention that they do use a DRM, but when we get a response from that state, they are not using. They could be the menu was updated for a certain time ago, but right now there's no person know, or maybe there's no recent study use a DRM. So the one responsive service, they say we don't use a DRM or recently. So sometimes we see those discrepancies. So originally we expect the response rate using DRM could be higher. Then we searched the National Transportation Library and indicated that acceleration use of DRM for the road studies in the past 50 years. So we find like 30 studies. Majority, they're using DRM. So in the recent years, maybe there's some growing trend to use more DRM, okay? So DRM was reported to be applied in critical application and involved the evaluation of extreme hydrologic events like the hurricanes and the tropical storms and the flooding study, and try to reduce the uncertainty for hydrologic estimates, such as use a lumped model. So applications of DRMs are for event-based hydrology most time because they use a point design rainfall rather than a continuous hydrological simulation. And based on the survey, so lack of expertise or training opportunity cited as a key barrier for the broad implementation of the DRMs for the current DOT. And so these are some suggested future research based on the current state, based on what we're thinking. So the development of guidance document and focus on the application of DRMs in the context of transportation infrastructure, okay, such as compare between semi-distributed and the grid-based or fully distributed DRM in the roadway design, okay, and explore the hydrologic condition for the DRM is most advantageous, okay, under what condition is better use DRM, or maybe what are the best practice for DRM modeling, because compared to the lumped model, it doesn't require more effort, requires more training to use a DRM. And then if you go further advanced and model, then it requires more training also. Determine the optimal data requirement to run the DRM application, cost-benefit assessment, use the DRM to support hydrologic decision-making. So these are some maybe sub-tasks in that area of research. Maybe help the DOTs to promote or use more DRMs, especially if they want to do the resilience design, they want to link to the climate impact, and the lump model will not do that at all, okay? And you go to that crossing, no matter how many times you try it, you get the same result, okay? Next type of research could be evaluate the use of special rainfall data with the DRM, data availability, how effective are predictions with the compared with the point estimate as like the Dr. Lai mentioned, the SHR2D watershed model. So they use a radar rainfall. I think one of the interview and study, they also use a radar rainfall, but for most of the DRM applications, they use the point design rainfall. And so this is dealing with the spatial rainfall data. And like example Dr. Lai mentioned, so in that watershed, you have about 30 different mesh grid. You have the rainfall distribution over there. So this could be some of research connect to the DRM. So even for the popular used one, HEC HMS, most time they also link to the point rainfall. But the HMS does have a capability use the radar-based rainfall, okay? And that's a little bit more challenging. Another type of research could be comparison between the application of event-based simulation using DRMs versus continuous simulation in which multiple hydrological stress. And because HMS, HS2D, they're dealing with event-based, but for the swing, you can do the continuous-based model, okay? And we also thank you for the input from our panel members. I think some of them are here, Matt and Roger and so on. And thank you for your attention. If you have any questions, I'll be happy to answer.
Questions for Dr. Fang? Time for one question.
Thank you.